Sorry about that.
Yes, hello everyone. My name is Boris Adryan, and I've been asked to essentially tell you a little anecdote about the Internet of Things, or better, how the Raspberry Pi is being used in commercial products. And I said anecdote because I said I can impossibly give a systematic talk about Raspberry Pi in IoT use cases because I simply don't know what people are doing. But I can probably highlight one or two reasons why people have chosen the Raspberry Pi in the past. So we don't have an Internet of Things yet, I'd say. These days, most of us do count themselves lucky. They probably have a thermostat that they can control with their mobile. But looking at all the predictions for the next couple of years, probably by 2020 we will all have fully connected living rooms with climate control, lighting control, air conditioning. They talk to our Fitbits, we have smart heating and communications, etc. I don't know who's going to pay for that, but at least that's at least what Gartner is trying to tell us when we're looking at 50 billion connected devices by 2020. So a typical architecture for the Internet of Things is that you have some sort of end device, and here in that case I'm showing a radiator. That end device is talking via some sort of radio protocol to a hub. That hub might be connected to your Wi-Fi. Your router then speaks to the internet. There's a cloud platform. Then there's yet another internet connection to the mobile network. And then in the end, via the cellular network, you can read what's going on with your radiator on your mobile phone. And this is a sort of architecture we're looking at quite often. And it's actually a problem because when you communicate to a consumer that there might be delay if you're trying to switch on the light using your mobile and it's not using your local Wi-Fi, that all of this is happening in the background can be problematic in terms of user experience. From the perspective of somebody who likes to play with things and develop and invent, you can look at this architecture like that. So the cost of development is relatively cheap on that side. So you can build your end device. Radio communications is very cheap, so if you know where to buy, you can get that for about £2. You can write your own applications for your phone, but as soon as you would like to play with the big guys, it's going to be very expensive. So if you want to be like a mobile phone company, you've got to have a proper investment. So I'm concentrating on the things on that side. And indeed, there are a couple of maker products. So for example, there's the Goodnight lamp that I also have here on my shirt. It's a set of connected lights. If you switch on one light, the signal is being relayed to the other light. And the interesting or Internet of Things bit about it is that you can have them in different places and essentially use it for communicate by unconventional means. There's been the Bubblino, which is a machine that blows bubbles if you use the right words in a tweet. Or probably more say serious use case is an internet-connected radiator valve from OpenTRV. So these are all products built by people like you and me, not big companies. Okay. So it's very attractive to use a Raspberry Pi for many of those things I've just been talking about, because the Raspberry Pi is an ideal IoT hub device. So we have Ethernet. We can very easily interface the Raspberry Pi via Wi-Fi or Bluetooth Low Energy. It has relatively little demands on power. And through GPIO, we can interface to hardware, or we can use communications from radio devices, for example. There have been commercial products using the Raspberry Pi. So here in that case, that thing is called OpenPi, and you can recognize the Raspberry Pi probably just by the little symbol on this compute module. So from the outside, it doesn't really look like a Raspberry Pi, but it is one. And that is one of these IoT hubs. There are a couple of other products out there. So Smart Living is selling a Raspberry Pi-based starter kit. I think you pay about £200 for a Raspberry Pi and SD card and an interface. Whether it's a good investment, I don't know. I don't own the product. I found this quite interesting. Pridokia, the Pi vending system, so that interfaces with a vending machine and essentially feeds back information about the temperature inside the vending machine and when it's filled. So people are doing that. My focus, of course I'm mostly a software developer, is software issues. So imagine you have a carefully configured SD card for your product, but now you need to roll out that new version of your software to 1,000 customers. And this is where the nightmares start. So how can you solve this most elegantly? So I'm going to talk about two things. One is called a technology called Docker, and the other one is a platform called Resinio. So I give you an exemplary problem. So say your project depends on a piece of hardware that your Raspberry Pi interacts with. If you have a Model B, it has 26 pins. The B Plus or the Model 2 have 40 pins. So you're looking at different pin definitions. Okay. If you look at CPU architectures, the Model B and the Model B Plus have just one core, and they needed a Node.js, so that's a particular programming language. They need a Node.js from Node ARM, which is one source. If you run the 4-core version, you get your Node.js from nodesource.com. So imagine that you have your product deployed, and it's based on probably the 3 different Raspberry Pis. How much that complicates your deployment process, the things you need to keep track of. So in a Docker view of the world, essentially all of these underlying complications can be packaged. You all have a defined interface, so as long as you tell your program, you can expect interaction with a couple of GPIO pins, and you can expect that you have a screen where you can show information, and your program is going to do this and that. You can't forget about everything that's underlying, that's more basic to the hardware. You need to essentially set up this Docker container, as one calls them, to really do the precise mapping between what you call a pin in your software and where it maps to the different hardware versions you're looking at. But the software itself can be then relatively independent of your hardware. So with Resinio, we have a platform that automatically deploys Docker images to the Raspberry Pi. So what you do is you install a base image on your Raspberry Pi, and it then connects to a GitHub-like platform at Resinio and downloads the appropriate Docker image to your Raspberry Pi. So you can imagine that if you have 1,000 customers, all with their Raspberry Pi, they poll every minute if there's a new version of the software. Send a request to the Resinio platform, and if you push a new container with an updated version of your software, they will automatically grab that software and deploy that container on the Raspberry Pi. It's all a lot less complicated than I probably just explained. They have very nice videos on their website. that talk you through the process of setting up Resinio. And even if you're not in developing products or deploying at large scale, you may want to give Docker and Resinio a chance, because what I found quite interesting is that they have this tool where you can set up a base image of the things that you will need for every Raspberry Pi in your house, for example. It's always using the same Wi-Fi, it's always using the same Wi-Fi password, etc. And if you're like me, you always want to have Node-RED on it. You can define that as a basic image, and then just use that for all of your in-house deployments. So it's really quite a useful tool, and I think Tim's probably quite tempted already to use it for the workshops in the future, because that has been one of our headaches when we run workshops here, that there's usually a base image that everyone should have for the entire course of 10 computers. So that was me, because I was asked to keep this short. I asked Resin whether they could send me anything that would help me explain their product. What I got is a bag of T-shirts. So, anyone M?
Yes.
There you go. Anyone L?
I'll take one. More comfort to that shirt.
Another L. Lucky use in the front end, because I can't go that far. And S. All right, so if you have any questions, I'm happy to take them, and otherwise we can move on.
How different is the base image to a standard Raspbian image?
In terms of what you have to do, very different. It is just an image file that you will ultimately write to your SD card. But you effectively say that you're going to deploy to a, say, Model Pi 2 with these credentials for your Wi-Fi, and then you have to write the Docker definition for pulling various packages in. So that can be slightly annoying, because I mean, usually when you set up a Raspberry Pi, you use apt-get on your local machine, and for making the images, you need to really think ahead.
Sure, I'm familiar with Docker, so I'm just wondering.
Oh, no, it's the same thing then. Yeah.
But you can't start with a standard Raspbian, say,
No.
image and then add Resin's capabilities on top.
No, you take their image, which can be a problem because there are certain things you just can't fiddle with.
Okay.
Okay. Good.
Thanks very much.
Oh yeah, and there are stickers.